Okay, as you can see from this lady's reaction, this is a slick section. So 7.3, notes on solving systems with substitution. We know how to substitute, right? We know how to replace things. So if I had a substitute teacher, I would not be here and somebody else would be, right? That's the definition of substitution. So when we are deciding if we're doing something by graphing or by substitution, we need to look at our two equations that we're graphing or two equations that we're using to solve our system of equations. So in this case, in number 1, I have two equations, and these two equations, there's a y equals. Not a y equals mx plus b. They're not both in y equals mx plus b. So this will be easier by substitution than it would be by graphing. Now, could you use graphing? Sure, you could solve this second equation here and be good and be able to do what you need to do. But I don't want you to because it's easier to substitute. Okay, so what do I mean by that? What do I mean? Well, y equals 18x. So anywhere where we see y, we're going to put 18x in place of that. So in this second equation, we're not going to worry about the first equation other than it's defining what we need to do. And then in this second equation, we're going to do that. So 2x. Here I have a y. I'm going to replace that y with my 18x. It's going to go there. So I bring down my plus sign. I put in my 18x. If that would have happened to be negative, I need to make sure I put a negative sign in front of that, or I'm going to have a problem. Okay? So exactly what it says y is equal to, everything that it says goes in place of my y. So if, like over here, I have an expression, that whole expression replaces my y. So that whole expression is going to go where my y is. Okay? But we'll do that one in class. All right. So now that I have this, can I solve this equation? Sure, I can. What can I do with my 2x and my 18x? Woo! I'm hoping you said you can add them together, Mrs. Hartlaw, because they're like terms. Woo, woo. Good girl. Good guy. Way to go. Okay, so I've got x's added together. I have 20 x's on this side, and I've got 20 on this side. But I have to have only one x on this side. What do I have to do next to get x by itself? I am really hoping you said divide by 20. Because that'll make that 1 and cancel it out. So I'll have x over here. And 20 divided by 20 is going to give me 1. So, am I done? I'm not. Because remember along a few lessons ago, I told you that all of our solutions are going to be in ordered pair. So I need an x, and I need a comma, and I need a y. I only have an x. How am I going to figure out my y? Well, I know what y is equal to. I know that y is equal to 18x. And now that I know that x is equal to 1, can't I use this up here to figure out what y is equal to? Sure. I can take this, and I can put it up into here. And I can do y equals 18. I'm going to replace my x with a 1. Great. Now I'm going to do the math. 18 times 1 is 18. So my y value is 18. All right. Fantastic. We'll do number 2 in class. I want to go over number 3. And that's all I'm going to do for notes tonight. And then we'll worry about the rest later. Okay. Do I have an x equals or a y equals? I do. I have a y equals right here. It's equal to all of that. It's equal to negative x minus 2. So wherever the y is, I have to put all of that in there. The whole box has to replace my y. So let's rewrite this top equation with that in there. So I'm going to bring down my 3x. I want you to put your plus sign. Then I want you to write negative x minus 2, that replaces the y, equals 12. That's it. That's all I want you to do. Now let's do some math. Let's solve for x. We know how to do this. We have 3 x's in this pile. How many do I have in this pile? Ooh, I hope you said negative 1. Woo-hoo. If you did, you're right. And then you have 2 x's in this pile, and negative 2 here is equal to 12. Fantastic. So, what do I do next? Remember, just a quick reminder, if I'm looking at PEMDAS, do I have any addition and subtraction on this side? I do. Here, the reason I combined these was because they were like terms. Now, I need to look at what's with my x that needs to move. Well, there's a negative 2 here. So, I need to get this negative 2 onto the other side because it's all by itself, and so is this. Okay? What do I have to add to this to get it to the other side, or to zero it out? I have to add a positive 2. What I do to one side, I have to do to the other. That will zero that out. So what do I have? Remember, here I'm always adding. Always add at this step. But whatever number you're adding is defined by the opposite of the number that's here, okay, in the expression. So 2x plus 0, that'll bring down my 2x, right? 12 plus 2 is 14. How do I get that x by itself? Well, there's multiplication and division involved, so I have to do the opposite, and I have to divide both sides by 2 to get x equals 7. So I can start writing my answer. My x is equal to 7. But what about my y? How am I going to find out what my y is? I'm going to use this because it already says y equals. So y equals negative, I'm going to put my 7 in there because it's the 7 minus 2. Why did I put those parentheses there? Just to hold on to the 7. They're not really needed, I guess. So I don't necessarily need to put those there. So negative 7. So negative 7 minus 2, or negative 7 plus negative 2, gives me, somebody owes me $7 and somebody owes me $2. They owe me $9. And that's my answer. Okay? We are going to go through 2 and 4 in class. And we will go through 5 and 6 in class. Those are a little tough. If you want to try them, go for it. We'll talk about them in class. Ask questions on how'd you get this, how'd you get that, so that we can really be excellent learners. Talk to you soon. God bless.